Welcome back to part 2 of this lesson on scientific notation. It's going to be chapter 4, section 5 of our textbook. We left off working problems where we had positive exponents, and now we got one where we have a negative exponent, and we have to take and change this back to standard form. And guys, this one is going to be super easy as well. I suspect they're going to do two ways. Yep, first way is going to be to write it as a power of a product. And we'll go ahead and highlight that, and what that means is now we have 3.27 times 10 to the negative 3. If you go into the lesson we did yesterday, we talked about how when you have a negative exponent, all you do is flip it over and change it to a positive exponent. So they've got this now listed as, they broke it down as 3.27 times 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1. They did that 3 times. Of course, 10 to the negative 1, flip that sucker, that's 1 over 10. Of course, there is an invisible 1 exponent there, but you really don't need that. From there, you would multiply that out, which is 3.27 times 1 over 1,000. And then from there, you can take and say, well, that's the same thing as 3.27 divided by 1,000, which is going to give you this little bitty decimal answer of 327. Let's see, that's tenths, hundredths, thousands, 10,000ths, millionths, 327 millionths, which you could put right here in the box if it made you feel all happy and stuff. And while this is a really good way to show your work on how to do this, it's a little bit excessive. Instead, we like the bounce the decimal method a whole lot better. For this one, you can see their animation. They're showing that the decimal is going to bounce to the left this time. Anytime you have a negative exponent, you just bounce a decimal to the left, the number of times that it shows in the exponent space. And when you do, you end up getting that final answer. Make sure you put a 0 in front of it like they did right there. So let's take and give it a try and see what happens from here. We have a problem given to us, 6.1 times 10 to the negative 2. Pause the video. You can solve it using either method, but I really recommend using method 2. So here I am. This is how I'm going to take and work my problem. I'm going to start off by writing my number 6.1. I'm doing the negative 2, so I'm going to go 1, 2 spaces to the left. Annexing zeros is needed. I'm also going to recognize that I have to have a 0 in front of it. So my final answer is going to be 0 and 61, whoops, I missed a 0 in there, 61 thousandths for my final answer. It really doesn't get any easier than that. 0.061, and hit too many numbers there, and check your answer. It checks. It really is that simple working with scientific notation. Now we get to watch a video about using scientific notation and technology, and this is going to help us to learn how to interpret scientific notation that has been generated by a calculator.
Graphing calculator and scientific notation. A calculator will convert numbers to scientific notation only if they are very large or very small. Enter 8 followed by 11 zeros, then press enter. The calculator displays 8E11. The E11 means multiplied by 10 to the 11th power. So, the value after the E symbol represents the exponent on the power of 10. So, 8E11 means 8 times 10 to the 11th power. Try a very small number by entering a decimal with 13 decimal places. Then press enter. The calculator displays 2.5E negative 12. This means 2.5 times 10 to the negative 12th power. You can also use your calculator to enter a number in scientific notation. Start by clearing your calculator. Type 2.389 times 10 to the 16th, like this. 2.389. Then press the second button. Next, press the EE button. which is written as EE above the comma button. Notice that it says EE on the calculator itself, but you will only see an E on the screen. Then type the exponent 16.
Well, I guess that's where the video ends. Okay then. That was very interesting. So we have this number on a calculator, 4e to the negative 7, and it says that they want us to write this in standard form. Well, the video they just gave us showed us exactly what we need to do to be able to do that. 4 is a number that's being multiplied by the power of 10, and the exponent is going to be a 7. So we're going to take and put the 4 right there, and we're going to put the negative 7 right here, and check it, and this would be the number written in scientific notation, 4 times 10 to the negative 7th power. Really pretty darn simple stuff there. Now, if we wanted to write that in standard form, we'd have to move the decimal, how many spaces? 7 spaces, and what direction are we going to move it? Well, it's a negative 7, so we're going to move it to the left. And that means our final answer is going to be, well, let's come over and find some scratch paper to do that on. So I've got, where's my pen? Here it is. 4 times 10 to the negative 7. So I'm going to take my 4, the decimal's right there. I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to put a 0 on each one of those. Put a decimal right here and another 0 there, so I'm going to have 1 and then decimal and then 1, 2, 3, 4, 5, 6. So I'm going to come back over here, 0.123456 and 4. Check my answer. My answer checks. Not that hard to do, but I mean, yeah, it's not that hard to do. Alright, now it's going to be your turn. Calculator screen shows the diameter of the moon in meters, and it wants you to solve the problem. So pause the video, make sure you're giving me good supporting work where I'm seeing your loop-de-loops where you're bouncing it, or if you're just really feeling froggy, you can do the times 10 6 times, whichever one works for you. Go. When I do it, I'm going to start with my 3.47, 474. It is times 10 to the 6th power, is the way you would write that in scientific notation. So 3.474 times 10 to the 6th, that's going to be C. And what else do we need to know? Well, let's see if we can figure out what final number that would be. That's 3.474 times 1, 2, 3, 4, 5, 6. Annexing our zeros as needed. So that would be 3474 with 1, 2, 3 zeros. So we're looking at 3,474,000. So that means that both B and C are going to be correct answers. And check it, and our answer checks well. When writing positive numbers in scientific notations, the sign of the exponent can be determined by examining the number in standard form. So we're going to take and select some buttons for words and examples to see how this would work. So if we're dealing with a number greater than or equal to 10, then the exponent is going to be a power of 10 is going to be positive. However, if we're dealing with a number between 0 and 1, the exponent of the power of 10 is going to end up being negative. Give some examples of this. Here we've got 5,860,000, which was 5.86 times 10 to the 6th power, where your exponent is going to be positive. And here I think this is 586 millionth, which they did the same, 5.86, but now it is going to be times 10 to the negative 4 power because they moved the decimal 4 spaces to the left. Pretty simple, nothing new. We've already talked about all this. They're just trying to hammer it home for you. So now we're going to look at writing 3,725,000 in standard form. Well, the goal is we have to get our decimal to land immediately after our first non-zero number. What's our first non-zero number? It's going to be 3. So from there, you've got options. You could take and say that's 3 times 725 times I'm sorry, 3.725 times 1 million, which then of course you could break that down as 1 million is 10 to the 6, because I'm sure all of you knew off the top of your head that 1 million is the same thing as 10 times 10 times 10 times 10 times 10 times 10. Count the zeros, boys and girls, count the zeros. And then from there you would say that scientific notation is going to be, well, this should be fun to try and do. So it's going to be just like they wrote there, 3.725. Oh, I didn't even get a start. Let's try again. 3.725. One more time. 725 times 10. And what was the exponent going to be? To the 6th power. Hit accept and check. And yep, there it is. Wow. Yep, we can do this. Now I'm kind of disappointed that the textbook appears that it's going to skip over the bouncy decimal part, because you know what? That's what everybody in the real world does. Your decimal's right here. The goal is to get the decimal right there. 1, 2, 3, 4, 5, 6. So we could rewrite that as 3.725 times 10 to the 6th power. And that's the way people in the real world do this. We don't multiply it by 1 million and then say times 10 to the 6 and all that kind of jazz. That's the way we do it in real life. Now it's going to be your turn to work one. You can do it the way the textbook showed you, which is overly complicated, or you can do it the way I showed you, which is stupid simple. Your choice. When I do it, I'm going to do just like I've shown you before. That's where I'm starting. My goal is to get it right there directly after the first non-zero number. 1, 2, 3, 4, 5, 6, 7. So it was 7 times that I did it. So I'm going to rewrite it as 1.414 times 10. Whoops, I don't know why I put an X there. 10 to the 7th power. Now, I'm not sure why they're going to 3 decimal places this time, because in fact, every other text I've ever looked at says that we're going to drop that last one and do it as 1.41 times 10. I did that again. Times 10 to the 7th power. That would be the way most people would write it, but there's nothing wrong with doing it that way either. Doing it the way I suspect the textbook's going to want to see it, we're going to do the 0.414 times 10 to, well, that's not what I meant to do. Right there, to the 7th power, hit accept and check, and our answer checks just fine. But what if they give us a wee little bitty number like this one right here and ask you to write that in scientific notation? Well, the way the textbook is going to tell you to do it is to start off just by discovering what the place value is. So I've got tenths, hundredths, thousandths, 10,000ths, and that's where we want our decimal to be. So we're going to do 3.16 times tenths, hundredths, thousandths, 10,000ths, and that's where we're going to put our 1. Of course, when you have 3.16 times 10, we read that as 1 10,000ths. That could be rewritten as 3.16 times 1 over 10,000, also known as 1 over 10 to the 4th power. From there, you could rewrite that as 3.16 times 10 to the negative 4, which is exactly what you would put there in the box if you wanted to type that in. I'm not going to do that though. Once again, this is overly complicated. I'm not sure why they're making you do it that hard. I'm going to show you an easier way, the bounce the decimal method, which is just so much easier. So I'm going to take their original number here. I'm going to jump over to my scratch screen right here, paste it in, and let's make it just a little bigger here so you can see it. Oh, no. Come on, baby, do what you're supposed to do. There you go. And then from here, I'm just going to take and start bouncing that decimal. My decimal is starting right here. I need to get it right here. So I'm going to bounce it 1, 2, 3, 4. I'm going to rewrite that as 3.16 times 10 to the 4th decimal place. That's the way I would show my work. I think you will agree that my method is a whole lot easier than their method is. And now you get to do one of these problems on your own. You've got the number written there. That's going to be, let's see, 1, 2, 3, 4, 5. So that's going to be tenths, hundredths, thousandths, 10 thousandths, 100,000. So that's 876 hundred thousandths is the way you would read that. And you get to solve this problem either way that you want, using their method or using my method. Using my method, the goal is of course going to be to get this decimal right here to be located, whoops, I put it in the wrong spot, right here, directly after your first non-zero digit. So I've got 1, 2, 3, and that's going to end up giving me 8.76 times 10 to the, we moved it 3 times, and that's a wee little bitty number, so it's going to be a -3. I'm thinking that on that last problem I forgot to include the negative. I sure did. Whoops, let me go back and fix that. That would have been to the -4 because we were still dealing with a wee little bitty number, and when we write those tiny numbers as exponent or scientific notation, they're going to have a negative exponent. This is a good place for us to stop this video. We will come back for part 3 here in just a minute as we finish looking at all the wonderful information they're showing us on how to solve these. And you want to talk about some exponential information? Look at all that work I've done there. That's pretty dang impressive. See y'all in video 3.